All right, so shifting gears here on this whole page, everything is about graphing lines or linear equations for lines. So everything on this page, number 5, number 6, number 7, and number 8, can be practiced with the R3 homework set that I have for you at the end of the module. And in this video, what I'm going to do is the first two, 5 and 6. It basically has everything to do with what is commonly known as the rate of change, and in the linear world we know that as slope. So in a rate of change, we're basically looking at the change in one quantity divided by the change in another quantity. And so for the slope, we're basically looking at the change in the y values, right? That's the first quantity that we have, and the change in x. Of course, you guys probably remember this from previous work as y2 minus y1, all over x2 minus x1, all right? And so we're still talking about the change in two changing quantities, in this case, change in y and change in x. So with that rehashment going on, right, for number 5, to find the slope, we just need to designate who is who. So since this is the first point, how about I let that be x1 and y1, and let this be x2 and y2. So to find my slope, we usually call that m. I'm going to take my y2 value, which is 5, subtract my y1 value, which is 3, and divide that by my x2 value, which is 4, and my x1 value, which is 2. So I'm basically using that formula and just plugging in the values that I determined for myself. 5 take away 3 is 2. 4 take away 2 is 2. So in this case, the slope is equal to 1. All right, and what's cool about this, or challenging, the slope is the same no matter how you calculate it. So if I just wanted to be different, and I wanted this to be x1 and, x2 and y2, and this x1 and y1, and if I plug them into that same formula up here, right, what we're going to get is the slope is equal to my y2, which is 3, take away my y1, which is 5, and then my x2, which is 2, and my x1, which is 4. And in this case, doing the math, we end up with -2 over -2, which is still 1. All right, so just make sure you determine who's who, all right, and then plug them into your formula, right? And because we're dealing with a line, the slope should be the same no matter what. So that's kind of a cool idea. So don't get too hung up on which one's x1 and y1 and x2 and y2. Just make a determination and throw it into the formula. Number 6, believe it or not, it's a very similar problem. What we have is a word problem, but we, pay attention. We have two changing quantities. In the year 2000, this population of this town was 2150, and in the year 2010, the population was 2020. So I can make this problem look like what we had in number 5. How about I create ordered pairs? The first ordered pair, right, is we have a year, 2000, and we have a population, 2150. And then if I'm going to choose my year to be the x-coordinate, my next data point would be 2010, 2020. And so now that I've reorganized the data, right, as to in two ordered pairs, we can see my changing quantities. I have a change in x and a change in y, again, or a change in a time value over a change in a population, if you want to give it raw data information like we're doing there. But we're using the same formula. So my slope in this case, or my rate of change, right, would be 2020 minus 2150 all over 2010 minus 2000. So I'm pretty sure the bottom is 10. Doing some scratch work over here, 2020 take away 2150. I'll have to borrow, and I think I get 7. I get oops, I did that wrong. My goodness. I was wondering what I was doing wrong, right? The idea is we're supposed to, good for you guys to see me make a mistake. There's more negative stuff. The population is actually decreasing. So how about I go 2150, and I'm going to take away the smaller number but my final answer will be negative because there's more negative stuff. So I apologize for that. Should remember some of my arithmetic, right? So we got 0, we got 3, and we got 1. So the top is negative 130. The zeros will cancel out, and we're left with negative 13. Negative 13 what? Well, because this is a word problem, we have meaning, right? This would be people per year. So as opposed to the problem number 5, where we're just moving from point to point that don't have any real life meaning, right? This one, right, the two changing quantities was time value in years and people value in people. So the change in people divided by the change in years gives me people per year as my rate. And that's why we also call this a rate of change. All right, so there's hopefully a memory jog of your slope. All right, and what we're going to do is use that slope to help us do some graphing and find some equation of lines, but I'll do that in another video coming soon. See you later.